Okay, so to these lectures, I will talk about maxima and minima. Okay, and we concentrate on absolute maximum and minimum and local maximum and minimum. Okay, so let us look at those in detail now. Okay, so absolute and global maximum and minimum. Okay, let us look at the definitions. Let's see be a number in the domain C, domain D of the function f. Then f of c is the absolute maximum values of f on D if f of c is greater than or equal to f of x for all x in domain. So therefore, in this case, you will see that we look at the whole functions. Okay, we look at the highest values. Okay, so then this is the idea about the absolute maximum. On the other hand, the absolute minimum is the smallest values, okay, output of the whole functions in the domain D then, okay. So therefore, again, if you look at this graph right here, you will see that to this one, f of D is the highest number. So therefore, in this case right here, this will be my absolute maximum. Okay, we say that is the value. Now value meaning what? It's just the output, the y values. And then the lowest number, the smallest number is actually is f of a. So therefore, in this case, f of a will be my absolute minimum value now. Okay, so this is the idea about absolute maximum and minimum. We look at the highest, the biggest number in the domain, absolute maximum. The smallest number in the domain, the smallest values, okay, in the domain is the absolute minimum. Then, how about the local maximum, or sometimes we call the relative maximum or the minimum now? The number f of c is the local maximum values if f, the values of f, if f of c is greater than or equal to f of x when x is near c. So in this case, we are not looking for the whole thing. We only look at nearby the number c, okay, to see if this is the biggest number, the biggest output, okay, around this area right here, okay. And then, of course, the local minimum of f, if f of c is less than or equal to f of x, when x is near c, okay. Now, actually, remember back to earlier at the beginning of the chapters 4.5, we talk about this. When we have the local maximum, basically, in this case right here, is we are looking at the change, okay? It's changing from increasing to decreasing. So therefore, in this case right here, you will see that if this is the C, then you will see that in this case, f of C is actually the biggest number around this area, right? The biggest output. So therefore, f of C will be my local maximum. On the other hand, if I have a local minimum basically is changing from the decreasing to increasing, okay? So then this is my local minimum. And then again, if this is C right here, then you will see that around this area right here, then f of C will be less than or equal to the rest of the function then. So therefore, in this case, f of C will be my local minimum, okay? Now, one thing about this is, when we talk about the local maximum and minimum, we are not looking at the endpoint. This means in this case, we are not looking at the A and this point right here. We looking anything in between the function, okay? In between the domain. However, when we talk about the absolute maximum or minimum, we also consider the endpoint as well, okay? So therefore, in this case right here, when we talk about this, then you will see that f of C is my local minimum, and then f of E is my local minimum. And f of B is my local maximum, and of course, f of D is also the local maximum as well. Okay, so this is how we define the absolute max min or the local max and min then. Okay, then now, definition. F has an absolute extremum at A if f of A is the absolute maximum or the minimum. F has a local extremum at A if f of A is a local max or min. Okay, so therefore again, next time if I ask you to find the extremum, then you know that we are looking for the maximum or the minimum. And then now, let us look at the extreme value theorems now. If f is continuous on closed interval AB, then f attains an absolute maximum value is f of C and an absolute minimum value is f of D as some numbers C and D in A and B. Okay. So what does this mean? It means that if we have a closed interval, then it's actually guaranteed that we will be able to find the absolute maximum or the minimum then. Okay, it's guaranteed. Oh, actually, I should say that it's absolute maximum and minimum. Okay, so let us look at the example here. Now you see that we have a closed interval here. Then this is absolute max. This is absolute min. We have a closed interval. Then absolute max and absolute minimum is actually at the endpoint. Sometimes, again, this is a closed interval right here. We may have more than one absolute maximum. Okay, it occurs at x equal to c sub 1 and c sub 2 then. Okay. Okay, so this is actually kind of like the idea about extreme value theorems now. Okay. And of course, this figure 2 is actually tell you that this is a local minimum, local minimum. And then in this case, this is my global. Now remember global meaning absolute, right? Global and local minimum. And then this is my local maximum. This is my global and local maximum then. Okay, then let's talk about the critical numbers now. A critical numbers of a function f is a number c in the domain f, such that either f prime of c equal to 0 or f prime of c does not exist. Now, we have two types of critical numbers, okay, or critical values then. The number c is stationary values if f prime of c equal to 0. That means in this case, if I know that f prime of c equal to 0, then this c is what we call the stationary values. It's also a critical numbers, okay? And cf of c is called the stationary point. Okay? The number c is singular if f prime of c is undefined. So if we have f prime of c is undefined, then this c right here is what we call the singular values. Of course, it's also a critical values as well. Okay. Then cf of c is called the singular point. If f has a local maximum or minimum at c, then c is a critical numbers of f then. And then let's look at this picture right here, right? So in this case, okay, and you will see that to this one, we will have some critical numbers, right? Okay, so let's see how many critical numbers that we have. Okay, from left to right, then we will have B, C, D, and E. Okay, we have four critical numbers. Within these four critical numbers, then again, if we have f prime of a number x equal to 0, then this is what we call the stationary, right? Then I will have x is equal to B, D, and E. And then if f prime of x is undefined, then we call it a singular. Then in this case, x is equal to c. Okay. Okay, so then this actually is the idea about how do we, again, identify the critical numbers or stationary or singular then. Okay, then now let us look at the following example now. Okay, so of course the endpoints, closed interval contain endpoints, right? But open interval does not, okay? Okay, so then let us look at the following example now. We would like to locate and classify all extrema, i.e. list whether each extremum is a local or absolute max or min. Also locate any stationary point or the singular points then. Okay. Okay, so now to this one right here, then let us look at this. I would like to locate the local maximum point. Okay, so therefore we will see that these 2 points, they are the local maximum points. So it is -3, 2, 4, 5. Okay, and then we would like to locate the local minimum. Then these 2, right? The local minimum. So I will have -5, -6, -1, -3. And now let us look at the absolute maximum point, okay? The highest, the biggest output, okay, which is this one. So then it will be -8, 6. The absolute minimum, okay, which one? Okay, this one is the lowest point, right? So then my absolute minimum is -5, -6, okay? And then now let us look at a stationary now. Stationary where the derivative is actually is equal to 0. So I have this one, I have this one, and then I have this one. So therefore the stationary point, it will be -5, -6, -1, -3, and 4, 5. Okay. And then now, how about singular? And then I know that I have one singular, which is -3, 2. Okay. And then endpoint, okay, so we have 2 endpoint, right? So it's -8, 6, and 6, 2. Okay, then now, how about my critical numbers now? Remember, critical numbers basically is x equal to, right? So it will be from left to right, I have -5, -3, -1, and 4 then. Is that okay? Okay, of course, now it is your turn. Now go ahead and try example number 2. Now to this example, number 2, this is the arrow, meaning what the function is continue going up. Okay, okay, so let's try this. Okay, so then now my local maximum point, okay, it will be this 2 right here. And then my local minimum is 2 point right here. So I will have 1, -2, and 5, -7. And then now my absolute maximum. In this case right here, we do not have any absolute maximum point. Okay. And then my absolute minimum, we have 2 of them. So the absolute minimum point, it will be -6, -7, and 5 and 7. Okay. Oh, by the way, if I ask you to find the absolute minimum values, okay, then in this case, it is -7 then, okay? Now remember, if the problem asks you to find the minimum values or maximum value, basically just the y, okay? Okay, then now the next one is the stationary, right? Okay, so in this case, the stationary will be this one and this one. So the stationary will be 1, -2, and 5, -7, And the singular must be this one and this one, because the derivative basically is undefined. So negative 3, 5, and 3, 3. Okay. And endpoint, we only have one endpoint, negative 6, negative 7. And then my critical number, x equal to negative 3, 1, 3, and 5 then. Okay. Okay, so now let us look at the next one. The values of the derivative at a local or relative extremum, okay? How do we find it? Let f be a function with a continuous graph. If a local extremum of f occur at cf of c, then f prime of c equal to 0 or f prime of c is undefined. The converse is not true. That's it. If f prime of c equal to 0 or f prime of c is undefined, then a local extremum is not guaranteed to occur at c f of c. Okay. Can you think of an example then? For example, like f of x equal to x to the power of 3, then we know that f prime of x is 3x squared. And of course, we set 3x squared equal to 0, then x must be equal to 0 then, right? Then f prime of 0 equal to 0. But we know that to the graph of x to the power 3, and at x equal to 0, this point right here is neither maximum nor minimum, right? Okay, so therefore make sure that the converse is not true then. Okay, so now let us try to do the following example now. I would like to find the critical numbers of the function, then say if the numbers are stationary or singular. Okay, so therefore again, how do we actually work on the problem? Of course, to this one right here, basically we need to take the derivative, right? So then let's look at the derivative then. Okay. And then now, what do we need to do? We need to find the critical numbers now. Okay. So in this case, because it is polynomial, so I know that I cannot find any number to make it undefined. However, I could find some number to make it equal to 0. So we are going to set 3x squared plus 12x minus 15 equal to 0. Okay. Then we find out that x equal to -5 and x equal to 1. So then now, in this case right here, we have critical numbers, x equal to -5 and x equal to 1. And then in this case, okay, how about stationary? Then we have x equal to -5, x equal to 1. And how about singular? Of course, we have none, right? Okay. Okay, so now it is your turn to do number 4 and number 5. Okay. Then, okay, so let's check our answer now. So I have f prime of x equal to 1 plus cosine of x. Then we would like to find critical number. Okay. And stationary. Then we will set 1 plus cosine of x equal to 0. Then I have cosine of x equal to -1. Then, of course, the easy way to do this problem right here is to graph it, right? Then to have it -1, basically we have this point, and so on and so forth. So then in this case, I will have x is equal to pi, 3 pi, 5 pi. Okay, or we could write it as x equal to pi plus 2 k pi, where k is an integer now. Okay, then now for the singular, we would like to have f prime of x is undefined. But of course, we know that we could not find any number to make the derivative undefined. So in this case, we have no singular. Okay. Okay, so then now let us look at number 5. Okay, now if you don't know how to do this one, but first maybe try to take the derivative first, and then I will introduce how do we actually do find the singular and stationary numbers now. Okay. Okay, so let's just try to take the derivative now. Okay, so this is what we have. Okay, so right now, what I would like to do is I would like to find the GCF. Okay. So in this case, basically the GCF that we could do here is we could take out 2/5. For the basis x, we take out the smallest power, and then for x minus 4, this term right here, or this factor, we take out x minus 4 then. Okay, so this will be my common factor now. So then now I take out 2/5, x to the -1/5, x minus 4. Then now, let's see. So I will have 2 x minus 4 plus 5 x to the power. Now the reason that we take out this is what is we would like to subtract. Okay. Now if you don't know why we subtract the -1/5 here, then let's consider this. If I have x to the power 4 minus x squared, okay. Now you see that when we try to factor, we would like to take out the smallest power, right? We take out the x squared. Then let's see what happened here. Basically, what do? You subtract 2 here, and then you subtract 2. This is actually the idea about factoring, okay? We factor x squared, then we subtract the power, okay? So this is the idea. So this is the case here. Okay, then now, let's see. So it is equal to 2/5 x to the -1/5 x minus 4. And then now we will have 2x minus 8 plus 5x then. Okay. Because again, this is 1 right here, right? Then now let us rearrange this. So I will have 2x minus 4, and then I will have 7x minus 8 over x to the power of 1/5. Okay. Or remember, this one basically is equal to, right, 5th root of x. Okay. Okay. And now let's see this one right here. Okay. Again, we have a singular and stationary. Okay. Then let us look at the first one, this stationary, meaning what? F prime of x equal to 0. Then in this case, you will see that to make the f prime of x equal to 0, we will have x minus 4 equal to 0. And also 7x minus 8 equal to 0, right? Okay. Then now, how about to make it singular? Then we will have the x to the 1/5 equal to 0, because this will make this undefined, right? So x must be equal to 0 then. Okay. So then we can make the conclusion now. We will have a stationary numbers x equal to 4 and x equal to h/7. We will have a singular x is equal to 0. And then now, if we want to find a quick, that's mean critical numbers, then x is equal to 0, 8/7, and then 4. Okay. Okay, so then now let's see how do we actually find the absolute extremum then. Okay, now here remember, if we have a closed interval, then we will be, by the extreme value theorems, is guaranteed that we will be able to find the local, that's mean absolute max and min. Okay, so if we have a closed interval, then to find the absolute maximum and minimum values of the continued function f on a closed interval AB, first, we would like to find the value of f at the critical numbers, okay, in A and B. And second, we will find the values of f at the endpoint. And then number 3, the largest of the values from step 1 and 2 is the absolute max, and the smallest will be the absolute minimum. Okay. So basically the idea in this case right here essentially is we would like to find, first, we need to find the domain of the functions, the continuous functions. Then we need to find the critical numbers, okay? And then now we create a table to actually check the points and check all the points, okay? And then compare the values then, okay? Then let's try our first example number 6 here, okay? Then first, we know that the domain to this problem right here is actually is between -1 and 2, okay? So this is a closed interval, okay? Then the second, we would like to take the derivative. Okay. And then number 3, we would like to find a critical numbers now. So I have 6x squared minus 1 to the square. Then we will have x equal to 0. Okay. And now, the step number 4, basically I'm going to create a table now. Now, the x value that we would like to put it down is the 2 endpoint, -1 and 2. Okay. And then now we would like to put down the critical numbers, okay? 0 and 1. Okay. Now, of course, you will see that -1 is also the critical numbers, right? Okay. And then now, what we need to do is we need to evaluate f of x equal to x squared minus 1 to the cube, right? Okay. Then now is -1 squared minus 1 to the cube. So then this is 0. Then f of 0, so minus 1 to the cube. So I have -1. Then f of 1. So I have 1 squared minus 1 to the cube. Again, 0. Then f of 2. 2 squared minus 1. So it's 27, right? So then now I have 0, -1, 0, 27. Then, of course, in this case, we know that my absolute minimum value is equal to -1. Absolute maximum value is 27. Okay, so this is actually is kind of like the procedures, okay? Okay, then now let us look at number 7 now. Now to this problem, basically we would like to find the domain of f and use calculator to find the exact maximum and minimum values, okay? Okay, so then let us look at this one. Then now you will see that the function f x is polynomial, so the domain is all real numbers. So meaning right now we would like to look at the domain of this one, this function right here, right? Now we know that that means if we have a square root, basically we want the integrand must be radicand, okay? Radicand must be greater than or equal to 0, okay? So this is exactly the idea. How do we find the domain? Okay. So we would like to set x minus x squared is greater than or equal to 0. Okay. Okay. So we have x equal to 0 and x equal to 1. We need to find the 0, right? And then the easy way to do this is work with the side charge. And we put 0 and 1 here. Okay. Basically, this is what we do. And then now we are going to, again, this is the f. Okay. So we would like to select a number in between. Okay. So then we know that when we plug in -1, so I have negative, positive, so this is negative interval. If I plug in 0.5, then this is positive. 1 minus 0.5 is positive. If I plug it in 2, then this is positive, and then 1 minus 2 is negative. So this is negative. So meaning in this case, the domain is in between 0 and 1 then. Okay, so this is how we find the domain algebraically then. Okay, then now let us try to work with B now. So B, we are going to use a calculus to find the exact maximum and minimum values. Okay, then now we need to work with the functions. And now we take the derivative. Okay. Okay, so maybe let us find the common factor. So I will take out 1/2 x minus x squared to the negative 1/2. Okay. Okay, so then in this case, I will have 2x minus x squared to the 1 power plus I take out 1/2, I take out this, so I will have x 1 minus 2x. So then now, okay, and now I will have 2x minus 2x squared plus x minus 2x squared. Okay, so I will have 3x minus 4x squared, and then 2 square root of x minus x squared. Okay, so then maybe let us try to factor this. So I could factor the x. Okay, so then now we will be able to find the critical numbers now. Okay. Then now, remember the next step is we create a table now, right? So I have x, okay. So it is between 0 and 1. Then in between we have 3/4. Then I have f of x is equal to x times square root of x minus x squared. Okay. And now we know that f of 0 is equal to 0. F of 1 is equal to 0. So the only thing is f of 3/4. Okay, so it will be 3/3/16. Okay, then now let us look at make the decision now. Okay, so my absolute minimum values is equal to 0, and my absolute maximum value is equal to 3/3 over 16. Oh, this is it. Okay. Okay, so then again, to this section right here, I introduced how do we find the absolute max and min, and to locate the local maximum and min, right? And also I talk about the curve numbers. And of course, the last thing is how do we actually find the absolute max and min, okay, from a closed interval then. Okay, thank you.